Let's take an example, spam emails, and let's see how you would do it using traditional way of programming or using machine learning or data mining. So if, let's say, you are interested to build an application that is able to flag emails, whether it's normal or what they call it, non-spam or ham email, against actual spam emails, right? So we need to teach a program, or let's say we need to build a program that is able to flag each email, whether it's spam or ham, like when you open your inbox, right, the email inbox, and you will see you have different categories. You have, let's say, ham, which is the emails you will normally check upon. And then if you miss out some emails, sometimes we go to the spam folder to look. Okay, so who has decided which email to go to which place, right? So that means there's some algorithm behind is working to filter out or to see, to flag which email is supposed to go to your inbox and which email should actually be sent to the spam folder. Now, if we take the just definition we said there, where we have the elements experience, task, and performance, right? So now our task is to flag emails, whether they are spam or ham. Now, the experience is the training data. That means we need to fetch all the previous emails we have, with the one with actual spam and the one that is ham. If you are building a traditional program, then you need that data in order to try to find something. So you sit down by yourself and try to identify something, how to identify those emails, that the spam emails, and how to identify the emails that are ham email or non-spam emails. And of course, we need the performance measure to see, let's say, for example, we take the performance measure P is the ratio of correctly classifying emails to spam and non-spam, for example. So we need that performance. As I said, we need it to see how good we are doing. So now in the traditional approach, what would you do? In traditional approach, of course, you need to study the problem, right? You need to understand the problem that you are working on. So the problem is we need to build a spam filter. So you start to understand. How do you understand? Let's say you collect historical data. You bring spam emails, non-spam emails. You sit down. You try to find some patterns. Let's say if a person wrote this phrase or if the person wrote this keyword, so that means this is spam emails. If these keywords were not found inside the email, so this is, let's say, non-spam email. So now I'm talking about traditional approach, by the way. There is no data mining or machine learning element. I'm talking just in the way that if you just open up any language you are already familiar with and start writing a program to flag those emails, whether they are spam or non-spam emails. So you try to identify, find, for example, keywords or phrases exist inside the spam email. And then what do you do? Then it comes to write those rules. So after you found these phrases, these keywords, then you go to your application and write these rules. So implement what you have found earlier during the, let's say, studying the problem phase. And then you write your application, writing these rules. After you write these rules, it comes to the time where you need to evaluate, to measure, right? The element P. We need to measure how good or how bad. Now, if we are satisfied, and you would be so lucky from first time to do it, then just you need to launch your application, your app. Your app is ready to go. Otherwise, if you are sad, what do? You need to go back and analyze the errors. Why you're not able to do well, right? Why your application is not working as intended to do. And then you go again to study the problem, amend those rules. For example, you have written inside your application and you go again to evaluation phase, and most likely you will fail probably, who knows. And then if you are good, then you go to launch. Otherwise, again, you go analyze the errors, maybe bring more emails, understand why those emails have been, for example, triggered or flagged as spam while while they are ham, or while they are ham, they flagged as ham while they are spam, and etc. You start again analyzing these errors and again study the problem, writing rules again, and so on. So just here, the steps are written to you, but actually just now what I have explained. So the step 1, you investigate spam emails to find words or keywords or phrases. Then step 2 comes where you write an algorithm to detect these patterns and phrases inside the text, inside the emails. And finally, you test step 1, step 2, see the output, whether what you have done is correct or not, and keep going, keep repeating step 1 and step 2 until everything is good, until you are good and satisfied that the application you have wrote or you have written is ready to go. So this is the traditional approach. Let's see what's the difference. So the difference is, as we said, we need, when it comes to data mining approach, right, or machine learning, we need to teach or to program the PC how to learn from this data. So in this case, actually, most of the steps are just same, but here it comes to the heart of the work. So instead of writing those rules explicitly, right, remember the word explicitly programmed. So instead of writing these rules explicitly inside the application based on the keywords and the phrases, what do? We use some statistical approaches, some machine learning algorithms to learn by itself based on the data. So we give this data, and instead of taking this data myself and try to figure out, find some keywords and phrases, well, I use some of these algorithms. These algorithms will try to help me to find some way to flag or to figure out whether such email is a spam or not. Right? And this is called classification problem in this case, where anyway, we're coming later to discuss about the types of machine learning. So the idea, the changes is here. So instead of writing these rules explicitly, now what I do, I take this data, I bring some algorithm, and then I bring this data. Of course, the data, you do not just simply throw it to, I give the emails, put them in the text file and just throw them to the machine learning algorithm. It's not that simple. It's not that way just straight away. Of course, you need some data preparation. Later, we also talk about. But anyway, let's say I have prepared the data as the machine learning algorithm would like to have, right? For you, it's okay. You have the text, you sit down, you look at the text, you find these keywords, but machine learning algorithms might not work the same way to learn from the data. So later we're going to discuss about it. So anyway, but the data is there presented to the machine learning in the way machine learning favors, the machine learning algorithm favors, and then it will start to work on this data to find something, to find some patterns, or to find a way to figure out how to flag an email, whether it's a spam or not. And of course, if the afterward, we evaluate the solution. We still need to evaluate. Remember, we have the element of performance. Always we have experience, which is the training data. And then we have the task, right? The task is simply what we are working on to flag emails. And then we come to the performance element where we need to evaluate our the output of this training algorithm, whether it's good or not. The same thing. If it's not good, then we need to study the problem. Maybe we didn't have good data. Maybe the data is irrelevant, for example. Maybe we brought some data that is not actually relevant to the actual problem. So we need to find out what is the issue. But again, we're not looking explicitly to find those keywords. Again, this is different approach. So we need to figure out why the machine learning algorithm is not able to learn from the data. Maybe the data has noises. Maybe the data is irrelevant, as I said earlier. Maybe it's not so good to teach the algorithm. And we start to figure out what is the issue. And then maybe the algorithm we use is not good enough for this kind of problem. Then we use another algorithm and so on until we are happy with the case. Then we launch our product or our application. Okay, so as it says here, automatically learns words and phrases from spam in comparison to those in ham emails. Later, we're going to talk about these algorithms. Now, another thing in data mining approach, and this which traditional approach misses, is in data mining or machine learning can be automated. What do we mean by automated? Automated means, let's say, again, back to the example of spam emails. Let's say the hackers who send those spam emails have changed their way or their style in writing inside the messages. So what would happen? All right, this is a good thing. Think about it. If you are writing your using traditional approach, and those hackers have changed their way of writing those emails. They change their styles. They use different keywords, different phrases. What would you do? In this case, let's say you need to go back, sit down, check those new style of emails from spammers and try to identify new keywords or new phrases and then amend your application again. But on the other hand, if I'm using machine learning algorithms, actually I can make this process because I taught the PC how to learn. So why do I need to spend my time? Just I can make it automated every time. Let's say I got my, spam filter, the old one based on the old data before the spammers noticed to change their way of writing. I have already built that model, right? I have already taught the PC how to do it. So now what I need to do, just I take new data and feed it again to the machine learning algorithm. And again, let it again figure out what to do. So keeping this in mind, actually, this is something new here, something good that the process can be automated. I don't need really to go back and do a lot of work. Just I can update the data and then again train the model again. Of course, the need to train, but again, the process is already there. Just I prepare the data or I update my data and then feed it again to the algorithm to find, let's say the house prices had changed dramatically. Something happened. Now, let's say the house was sold just 1 month ago, used to be sold these kind of houses, let's say 100K. Now suddenly something happened in the market, something dramatic, and the houses prices have jumped to 200K. The house 1 month ago was 100K, now it's 200K. Then what I need to do, I collect again, I updated the data, historic data I got for the houses that has been sold. And then I feed it again to the linear regression, for example. And then the linear regression will find another mysterious equation. So you see now, actually, there's no fitted one equation that you can use, for example, especially when I talk about linear regression. And it's my favorite subject because it's easy to understand when we compare to the traditional, like calculating the area. So now I feed the new data to the machine learning algorithm, the linear regression. Linear regression will find another line or maybe updated it, not so far from the old equation, but it has some tuning, some changes. And then again, I evaluate, I'm ready to go. Excuse me. So the idea is machine learning is able to be automated, while traditional approach will be hectic, right? And simply it might be, let's say you spend 1 month writing traditional program and then all of the sudden the spammers have changed their way of styling. So simply you have to stop there and to figure out, or maybe 1 week, and then only then you need to write the rules again, amend them, change them, and then launch your application again. While here, I can just make it automated process.